All right, so we are doing solving quadratic equation. So we're solving quadratic equation by factoring. All right, so quadratic equation, this is one way to solve quadratic equation. But factoring, the problem with factoring is not everything can be factored all the time. Remember doing prime polynomial? So in future, we'll talk about solving quadratic equation by completing the square and quadratic formula, but that's for future. So the form of your quadratic equation, the general form is ax squared plus bx plus c equal to 0. All right. So anyway, so every time we're solving quadratic equation by factoring, we need to make sure that our equation is set to 0. Are we good? All right. So before we go into a problem, let's look at a property, very important property called a zero factor property. It says if A times B equals 0, then either A is 0 or B is 0. So if you have two things multiplying together, right? We have two things multiplying together and giving out 0. Two or more things, it could be three things too. So if you have two or more things multiplying together and gives you 0 as an output, then at least one of that thing has to be 0. Are we good? There is no way you can take two non-zero number, multiply them and get a 0 out of that. Are we good? So that property, so we're mostly going to be doing factoring, and at the end we apply this property for the solving purpose. All right. Everybody okay with that? All right, so say you have something like this. It says solve x plus 2 inside of parentheses, and then x minus 6 equals 0. So this, so it says solve, that's why we're seeing an equation. We solve equation, right? But if you look at the left side of it, this thing is already in a factor form. This would be the very last thing you would get when you factor a trinomial, right? So I have this times that. So these two things are multiplying together, but what am I getting as an output? 0. So if I have this or that multiplying together and giving me 0, then using the zero factor property, when you have two things multiplying together and giving you 0, then either the first thing is 0, right? Or the second thing is 0. Very good. So basically we take our factors and set them to 0. Now once you get to this point, it's just a matter of getting x by itself on here. So if you look at the one on the left, well, how do I get x by itself? Well, we subtract 2, right? You get x equals -2. This is one of the solutions. And if you look at this thing on the right side, you add 6 and you get x equals 6. This would be your other solution. So your solutions for this particular equation is x equals -2 or x equals 6. We good? Okay. So here's your second equation. It says, well, of course it says solve. You have 2x squared plus 9x minus 5 equal to 0. 2x squared plus 9x minus 5 equals 0. All right. So how are we solving this? By factoring. By factoring. There are a couple other ways to solve but that will be done in future. So this is your quadratic equation. Quadratic equation because you have equal sign. This left side is quadratic because the highest power, the degree is 2, right? All right. So every time we're solving quadratic equation, we need to be at this point where this polynomial is set to 0. Very good. If you do not have 0 on the right side and something else, then you need to bring that over to the left to ultimately get a 0. Are we good? All right. So, is everybody fine? Now, what we do is that AC method from last time. What's your A on this thing? 2. What's your C? -5. So we take our A and multiply with our C, right? So what do I get when I multiply 2 times the -5? -10. All right, you can write your A, C, B, A, B, C like we've done, but it's your A times C. So 2 times the -5 gives me -10. Then I'm looking for two numbers. I'm looking for two numbers that multiplies to -10, but at the same time also adds up to +9, right? So I need two numbers that multiplies to -10 and at the same time would add up to +9. So what two number multiplies to -10 add up to +9?
-1.
And 10? -1 and 10? Perfect. Are we good? Then we copy the first, we copy the last. Of course, we keep up with the 0 part, that's just extra this time, right? And we break the middle one. We're not going to write 9x anymore. Rather, we're going to use -1 and 10 for that. I am going to put +10 first. You can put whichever you want to. Is everybody fine with that? All right. So now I have 2x squared plus 10x minus 1x minus 5 equals 0. The next thing we do is called factor by grouping, right? We take the first two, and then what can we pull out from the first two?
2x.
So we can pull 2 and then x. 2x comes up, right? That's the GCF of these two term. And that is going to leave me with x plus a 5. Perfect, x plus 5, right? And then you have this negative sign that you drop. And then you repeat this the same process with the last two. So what pulls out from the last two? So negative, we've already got a negative. 1 pulls out because these two have nothing in common. When there is nothing in common, 1 is always a factor of everything, right? So 1 pulls out, and we are left with x plus a 5. Remember, these two have to be identical. They are. -5 divided by -1 is a +5. Then you still keep up with the 0 part. And then we have x plus a 5. And then we have 2x minus 1 equals 0. So everything to this point is something we've done in the past, right? The only difference is now it has equal sign and a 0 on the other side. This is where your zero product property or zero factor property that we wrote earlier comes in play. So now at this point I have that times that. I have two different things multiplying, but giving me what as an output? 0. For these to multiply and give me a 0, either this has to be a 0 or that has to be a 0, right? So basically, what we do here is we take our factors and then set them to 0. So we're going to take both of our factors, set them to 0 each. So we have two equations. And we just get x by itself on both of these. On the left one, to get x by itself, you subtract 5, which gives me x equals -5. So this is one of the solution. We good? the one on the right side, we want to get this x by itself. So we add 1. I have 2x equals 1. Then we still need to what? Divide by 2. And then I get x equals half. So these are your two solutions. Remember, there are two factors, two different factors. That's why we're seeing two different solutions. The number of factors determines the number of solutions. Are we good? Sometimes these factors might be the same. You still get two numbers, but those two numbers are the same numbers. Are we good? All right. Stop. Thank you. All right, so the next one, so you have x parenthesis 2x minus 7 equals 4. So what we need to do here is we need to take this x and distribute this in. All right, we good? So you have x times 2x is 2x squared, right? And then x times the negative 7 is negative 7x. And then you have 4 on this other side, right? Is that good? All right, so now this looks a little better. This looks more quadratic than this did earlier, right? The power of 2. We have trinomial, even though not everything is on one side, right? So, so for us to be able to solve this by factoring, remember we need to have that equation set to 0, right? So we need to move this 4 over to the left side so that I have a 0 on the right side. Does that sound good? So when stuff are not in equal to 0 form, we need to get it to that form, at least for factoring. So you have 2x squared minus 7x. What happens to this positive 4 when it comes to the left side? It becomes negative 4. All right. Then you are at the same point like the last problem. So we do negative 4 times 2, which is negative 8. I need two numbers that multiplies to negative 8, add up to negative 7. So two numbers that multiplies and gives me negative 8, and the same two numbers add up to negative 7. Be negative 8 and 1, right? So we then copy the first, copy the last. We have to keep up with this equal to 0 part. And then the middle one is now broken as negative 8x plus 1x or plus x. Right. Now we do factor by grouping, where we take the first two and then what comes out from the first two? 2x comes out, and then we're left with x minus a 4. Then this plus sign, drop it down. The last two have nothing in common. That's when you take one out. And you have x minus a 4. And then you get x minus 4. 2x plus 1 equal to 0. Now you have your factors. Of course, you have 0 on the other side. This is where we use that zero factor property, the zero factor rule. All we now need to do is take each of these factors and set them to 0. And you get, for the one on the left, the goal is to get x by itself on both of these. So you need to move this negative 4 over. Negative 4 goes to the other side, becomes positive 4. This would be same as adding 4 to both sides, right? So this is one of the solution. Similarly, on the second one, again, the goal is to get x alone, so probably start out moving 1. So when this 1 positive goes to the other side, becomes negative 1. Then you divide by 2. Then you get x equals negative half, and that would be your other solution. So the two solutions we have are 4 and then negative 1/2. Remember, quadratic equation have a power of 2, right? The degree. So the degree of the polynomial basically tells you how many solutions you're going to get. So just because the highest power was 2, we should already know that there should be 2 answers. Sometimes those 2 numbers are the same number, right? But that's when we have repeating factors, but most of the time you get 2 different solutions. All right, thank you. All right, so let's look at this thing. So solve by factoring. This is still solved by factoring. However, if you look here, you're seeing a power of 3. We've never seen a power of 3 before, right? Same thing here, power of 3. So let's look at this one. The highest power is 3, right? How many solutions are we expecting at the end? 3 solutions. Now those 3 can be the same solution, but highly likely to get 3 different solutions. All right. So we're solving by factoring. That means I need to bring this 4x to the left so that I get a 0 on the other side, right? So what happens to this positive 4x when it comes to the left? Becomes what? Negative 4x, and you get a 0. We have to get a 0 on one side if we're solving by factoring. Are we good? Now this is not a trinomial. I don't see 3 terms, so we're not going to do AC method on here, but rather just grouping, right? So what can I pull out between these 2? What do they have in common? X. So you pull x out. All right, very good. You keep up with your 0, of course. And then what do I have inside of parentheses after taking that x out?
X squared minus 4.
X squared minus 4. Very good. So this is a factor. This is also a factor. Is everybody fine with that? So I have x. I need to keep on putting those x down. This is the greatest common factor. The GCF is what we pulled out. I hope you all remember this from maybe last class before. Can we factor this? How can we factor this? Remember, this is the difference of 2 squared.
X minus 2x plus 2.
X minus 2x plus 2. Perfect. X minus 2x plus 2. So if you look at the very last line, how many factors do I have here? 3 factors. That's where your 3 solutions are going to come from. Are we good? Is that fine? So I have this times that, giving me a 0. All right, for that to be true, either that has to be 0, which gives me an answer right away, right? Or x minus 2 equals 0, which means x would be what? Positive 2. Or x plus 2 equal to 0, which means x equals what?
X equals
Negative 2. All right. So we have 3 different solutions, 0 to negative 2. And we already knew we were going to get 3 solutions at the end, right? And these are your solutions. So when you only have 2 terms, now look at this one, or 4 terms, then we do not do AC method, all right? So this is also cubic. That means how many solutions am I expecting? 3 solutions, hopefully 3 different solutions. Some of those solutions may repeat. This is still factoring. That means I need a 0 on one side of the equation, right? Which also means I need to take these 2 and move it to the left side, possibly, right? Is that fine? Everybody okay with that? So what happens to this, let's do one at a time. What happens to this x when it goes to the left side? Becomes negative x. Good. What happens to this positive 5 when it goes to the left side? Negative 5, and I get a 0, right? I get a 0. Is that fine? Alright, so when you have 4 terms, or 2 terms, we do grouping, right? Factor by grouping. So take the first 2. What comes out from the first 2?
X2.
X squared. Nice. And then that leaves me with x plus 5. Your minus sign, you drop it down. And then what comes out from the last 2?
X plus 5. 1.
1. When there is nothing in common, we take 1 out. And that is going to leave me with x plus a 5. It has to keep up with the 0. Remember, negative 5 divided by negative 1 is positive 5. So it will ultimately match. Alright, and then you have x plus a 5, x squared minus 1 equal to 0. Wait, we were saying 3 solutions, right? But we only have 2 factors at this point. That means something else could be factored here, right? So between these 2, one of these can be factored out further. Which one would that be? The second one. It just looks like this. It just has 1 in there, right? So you have x plus a 5. How do you factor x squared minus 1?
X plus 1.
Plus 1. X minus 1. Perfect. So we have 3 factors. To get our solutions, we take each of these factors, set them to 0. Alright, so these are your 3 factors that we've gotten down there. So if x plus 5 equals 0, what is x equal? What does x equal? Subtract 5, right? You get negative 5. This is one of your solution. This is same as moving, you know, that moving I talked about. So if x plus 1 equals 0, then x would be negative 1. You take your positive 1, move over, becomes negative 1. And then this one would be x equal positive 1. We move negative 1 over, becomes positive 1. So we still have 3 different solutions. We knew we would have 3 solutions. We just didn't know whether they would be same or different. So sometimes these, you still get 3 numbers, but they may end up being same numbers. That is when we have repeating factors. All right. Most of the time you end up getting different numbers. But anyway,